In this video, we're going to be covering exterior lighting, except the headlights. We covered the headlights in the last video. We're also going to be looking at interior lights, and we're going to look at the trailer wiring. First, we're going to take a look at the park lights, tail lights, license plate lights, side marker lights, if it has side marker lights. This image on here, so you can see a tail light assembly. This light is going to be visible from the side of the car, so it would not have side marker lights. Park lights are going to work in both the park light position and the headlight position. It's a simple power side controlled circuit. All the light bulbs are going to be grounded. They're all wired in parallel. There will be 194 bulbs, 3157 bulbs, like this one here. This will be the dim filament, and then the brake or turn would be the bright side filament. Not too much difficulty in being able to diagnose or work with these circuits. The brake lights are going to be a simple power side controlled circuit. This is showing you the brake switch that's going to be located on the brake pedal. This one is showing you a single switch inside of the brake switch that's going to be mounted on the brake pedal. Most of them that you work with, you're going to find that there's 4 wires or even 6 wires connected up there. What most of the manufacturers do is they will have 2 or even 3 switches located inside of that single housing. This switch is normally open. When you push on the brake pedal, it's going to close that. The other switches are typically normally closed. They will open as you push on the brake pedal. Those would be used for the torque converter clutch, cruise control, other input. And this one, when we press on the brake pedal, it's going to put power to the stop lamps or the brake lamps. This has the center high mount stop lamp that was required starting in the early 80s. This circuit is simple. When you get to the circuit where the brake and turn signal are shared, that becomes much more difficult. Take a look at the turn signal circuit. We're going to start off taking a look at the flasher unit, which is shown right here. This is a 3-terminal one, which most all the newer cars have a 3-terminal one like this. Or this is going to be combined in part of the body computer. This is electronic. Anything electronic has to have power, has to have ground, which this has here, and then this is our output. So here's an example of a 3-terminal one. If you have an older vehicle, going back to the 90s, earlier than that, those will typically have a 2-terminal one, and we'll take a look at that one a little bit later. From our output here, we're going to go this direction, and it's going to come up to here. This was actually a 4-page wiring diagram, which I only brought 3 of the pages over, but I drew in with the red what are missing from that other wiring diagram. From the turn signal flasher, it is going to go to the turn signal switch. Turn signal switch is going to be part of the multifunction switch in the steering column. When you have right or left turn, if we move it to either side, power is going to come to one bulb. It's going to come over to our turn signal indicator that is on the dash, and then it's going to come over to the third bulb. So either direction you turn it, we're going to have 3 bulbs working either on the left side or the right side. With this style of flasher, there's a logic circuit inside there. It's going to watch if one of the bulbs burnt out. It's going to see that there's less current flow, and it'll flash the lights twice as fast. The older ones work different than that. This is also the flasher for the hazard. And this is our hazard switch over here, which you can't see because I cut it off. This fuse right here is hot with the key on. This fuse is hot at all times. Turn signals will only work with the key on. When you hit the hazard flasher, this is a gang switch, so these are all 3 going to come over here. This is what's going to allow power to come to our flasher unit, even with the key off. From our output here, it's going to come over this direction to here, which is then going to come this direction, and that's going to come to one of the lights, and you can follow it from each of those wires. If you pause the video, you can look at it, and you will see that all 4 of our lights, 2 in front, 2 in the back, plus the turn signal indicators, are going to be flashing. About it for this particular circuit. Again, not a whole lot of problems on this. If you get these newer flashers where they are flashing twice as quickly, and you take a look at it, there's no bulbs burnt out. What you want to do is put it in the 4-way flasher, Then take a look at your 2 lights in the rear and 2 lights in the front and see if one is brighter than the other, because a little bit of resistance or a loose connection will fool the module into thinking that there's a bulb burnt out, so it will flash twice as quickly. Here's where it gets more difficult. This is an older vehicle. This has the shared brake and turn in the back of the vehicle. This filament here and this filament here are both the brake light and the turn signal light. For the left side, this one over here, the 2 for the right hand side. I will point out on this that even though this is a manufacturer's wiring diagram, they made a mistake on this. This side here is the right turn, this side here is the left turn. Ignore that part there. We have 2 flashers. This one here is the hazard flasher. This one over here is the turn signal flasher, and you will see that these are 2-pin. They're electromechanical. Taking a look at these at the beginning here, you see there's a heater element. This normally closed switch is a bimetal contact. Current's going to flow through there. This heater is going to cause that bimetal. The one metal heats up and expands faster than the other one, and it causes the switch to open. Current stops, cools down, closes, and that's where you get your this switch snapping open and close. On the newer vehicles now electronic, they actually generate that sound with the computer. Taking a look at the hazard flasher, you see we still have the heater, we still have this bimetal, but it's normally open. Current's going to flow through here, through our cold light bulbs. When this heats up, this is going to close the contacts. Now current will flow through here rather than through this heater, cools down, pops back open. This is how a heavy-duty flasher was wired. This was how the standard-duty flasher was wired. When you go to replace them, you'll see that it says heavy-duty on the flasher units. That means it's wired like this. It's wired in parallel. You can replace a standard-duty with a heavy-duty. It will work just fine. If there's a heavy-duty on there and you put a standard-duty on it, the lights are going to blink really fast. It's just going to sit there really quick. Hopefully you will know that you need to put a heavy-duty flasher on there. The other thing is, if you have a standard duty flasher like this, and you see down here there's a trailer tow package, when you add a trailer, it's going to add at least one more bulb to the circuit. The standard duty is going to flash too fast. The point that I'm making here is if you have a newer vehicle and it flashes twice as fast, it indicates that there's a bulb that's out. On the older ones, if they flash too fast, it means you've got too much current flowing on there. You need to put a heavy-duty flasher on. Now let's take a look at how it works. First thing we'll look at is the brake circuit. Here's our brake pedal switch. This one goes to the cruise control, doubled in the connector. Then it comes to our multifunction switch. Comes over here to the center, and we have normally closed contacts coming to each side. All 4 brake lights will come on. For the turn signal, let's say that we hit the right turn signal. Now, coming from our standard duty flasher, it's going to come through our normally closed contact there to each of these. 2 lights in the back are going to flash. This is going to come over, and this, if you went over to the other wiring diagram, what you would find is these were connected there. And that's going to make our right front turn signal flash and the indicator on the dash. This one again is a dual filament bulb. This was an older vehicle, so this would have been 1157. This was the bright filament. That would be the dim for the park lights. When you go to the hazard flash, this is going to be pulled over here. Turn signal flasher is taken out of the picture. All 4 of these are gang switch. Power is now going to come from our heavy duty flasher, and it's going to come to the lights on the left side. That one doesn't go anywhere. That's if you hit the turn signal, it would still work. And then it comes here, and there's the lights in the back of the car. This one comes this direction for indicators on the dash. All turn signal lights on the outside of the vehicle will be flashing. If you do hit the brake pedal on this with a shared brake and turn, that's going to put power over here, and it's going to put battery voltage on this side of the flasher. So there's going to be battery voltage on the top side, battery voltage on the bottom side. Hazard flasher is out of the picture. On these systems with a shared brake and turn, when you hit the brake, all the lights will come on steady. Your indicators on the dash, lights in the front, lights in the rear, they all stop flashing. Went through that kind of quick. You may want to watch this a couple times or pull up a wiring diagram and study it, because this is one of the more difficult wiring diagrams for our exterior lights. Fog lights or driving lights, if it is a manufacturer installed or an option from the vehicle, they're going to be wired up, and you can test this. You turn on the driving lights or you turn on the fog lights, and then you turn on the high beams, and you will see that your driving lights or fog lights will go out. There is a difference between driving lights and fog lights, and we'll take a look at that on the next slide. If you're installing aftermarket lights on there, you're going to use a relay. You want to put this relay up close to your lights so that you have less wiring. It saves you some on the cost of the wiring. They're also going to have less of a voltage drop, so your lights will be brighter. Wire the lights up to ground, and then it's going to wire up to pin 87 of your relay. There's laws governing how high the lights are supposed to be mounted. They have to be X number of inches above the ground, and they can't be more than X number of inches high. I don't remember off the top of my head what those numbers are. What I do know is when you get the four-wheel drive vehicles and they have the light bar up above the cab, those lights are too high. They're not legal on the street, and they actually have to be disabled so that you can't turn them on. Just having the switch in the off position, you can still get a ticket for that. When you buy the aftermarket kits, they will usually come with a cheap ISO or Bosch style relay. It'll probably work just fine. If you have problems with it, spend the money, get a little bit better relay, because these relays really are good relays. Just there are some cheap ones that are out there. Power is going to come up to pin 30. Make sure that it is fused. The kits that you buy will typically have an inline fuse to put on there. On this one, they've got their switch over here to the control side. Again, they're using power coming up to here, and it's fused. When they flip this switch on, this one's coming up to 85, 86. Wire 86 up to the high beam headlights. With our 70 to 90 ohms that we have on the control side of the relay, your high beams, when they're off, they're going to have about an ohm, maybe even less than an ohm from between the two of them. That's going to be a really good ground path for that relay. That will not even make those high beams glow. It's just going to be current flowing through there, but it's not going to do anything to the lights. When you turn on the high beam, power is going to be here. We're going to have power on this side, power on this side. The relay is going to shut off. That will shut off your driving lights or your fog lights. When you're wiring these up for a customer, it needs to be done this way. It is illegal to have those lights on while the high beams are on. The customer can get a ticket for that, and the customer can come back and force you to pay for that ticket because you need to wire it up this way. There's a lot of people on there that are putting driving lights or fog lights on. They want them to be on. If you're doing that for yourself or a friend and you're willing to pay the ticket, if you get caught doing it, go ahead. But for a customer, you don't want to do it that way. This is how I recommend is wiring up the control side of the relay, ground it through your high beams. Now, the difference between a fog light and a driving light. So PIAA is a company that makes a lot of lights, and I'm not pushing theirs. I just found this image and thought this was a really good one. You can see this light pattern right here, where it's going to go a relatively short distance in front of the car. It's going to be spread out. Besides being a short distance, it is also going to be pointed down. That's your fog lights. You don't want fog lights pointed up because you don't want it to reflect the light back at you. A lot of people think that, well, if it's an amber light, it's a fog light. If it's a clear lens, it's a driving light. That's not true. It's how the pattern is cut in there. The driving lights, those are going to have the pattern that are coming out something more like this. It's going to light up farther down the road, but it's not going to light up to the side. These are the ones that are going to get into the eyes of the oncoming traffic. Fog lights can stay on if they're mounted correctly, aimed correctly. It's not going to interfere with the sight of the vehicles that are coming at you. Hideaway headlights. I'm not going to go into a whole lot of detail on this because who's using these anymore? I don't know of anybody who's got these on the newer cars. If you're working on an older vehicle and it has the hideaway headlights, if there's a problem with them, they have a manual knob right here. First time that I dealt with one of these, got in there, this was on I think an 84 Pontiac Fiero. Headlight wouldn't come up, so I got in there. You start turning that knob, and you turn the knob, and turn the knob, and turn the knob, and you get tired, and muscles cramping up, you change hands, you turn the knob, and that light's slowly coming up, and it's back over, and you're turning it, and it finally gets all the way up. Well, there's a switch in there when it gets all the way to the top position, and this thing goes right back down. That knob spun in my fingers, took some skin off. I learned, if you're going to manually crank these things, pull the fuse or pull the relay so that it doesn't take off on you. The only time I've ever had to deal with these is when the car's been hit and it jams up inside there. Either manually crank it so that they're up and stay up, or if the customer still wants it to work, you're going to have to bend some metal to get it to operate again. Manufacturers typically will put a third position in the headlight switch, or I'm sorry, a fourth position in the headlight switch, so that these will come up, but the light doesn't come on. That allows you to wash the light or to replace the bulb. Backup lights, again, is another fairly simple circuit. We have a couple lights, ground coming here, power side controlled. The switch for the backup lights on a lot of vehicles is mounted on the transmission. You can see from looking at this switch here, this is not just a simple switch. This is also your park neutral switch, backup light switch, and there's going to be other things that are in here also. The backup light switch may be mounted on the shift linkage, so it may be in the center of the vehicle, center console of the vehicle. It may be in the steering column or on the transmission. When you go to replace these switches, some of them, just mount them on, it's done. Others of them, there's an adjustment on here. You need to look up in the service manual to find out that adjustment procedure. If you don't get these adjusted correctly, backup lights may be coming on when you're in neutral, and you may have to put the car in reverse to be able to get it started. Interior lights. So the one that I'm showing you here is the early system. This was a real simple system. You open the door, switch closes, interior lights come on, close the door, switch opens, interior lights shut off. Power is coming through our courtesy light fuse, hot at all times. We have one light, two lights, and then this is coming over. We're going to go without the power door locks. Comes down here, and there's a bus bar here, which feeds power to these three bulbs, to this bulb, and if you have a station wagon, to another bulb here. People will look at this and think, oh, there's 5 or 6 interior lights. There's not. This light here has its own ground. It is controlled individually. This one is not part of the interior lights or dome light circuit. This light and this light are the map lights or the reading lights. Again, they have their own grounding circuit. These are focused lights. The idea is that a person's in the car, they can turn on their map light or the reading light, and it doesn't interfere with the driver's ability to see out of the car. This is not part of the dome light circuit. In this vehicle, we've got the 2 footwell lights that are under the dash. We have this one, which is up on the ceiling. If you have a station wagon, you would have another light over here. Interior lights on this vehicle is going to be 3 or 4, depending on if it's a station wagon or not. Looking at the ground side of the circuit, it's going to come down to our instrument panel dimmer. Most manufacturers, as you turn that dimmer all the way to one direction, it'll turn on the interior lights. I have had more than one customer bring their vehicle in. Battery goes dead. They're telling me the interior lights won't shut off. I reach in there, turn that dimmer, interior lights go off, and then watch them react and get embarrassed and, oh, I didn't know it would do that, or They blame somebody else. I don't know who turned that. This is also wired in parallel with, on a 4-door. We've got any one of the 4 doors that will open. When the door opens, the switch closes. Turns on the lights. When you close the door, the lights shut back off. As we started getting into the late 70s, early 80s, the manufacturers were figuring out that, hey, we need to do something for the customer. So they put a timer, which was computerized on there. These bulbs were now an output for a relay, and that relay was controlled by the timer circuit. These switches were an input. When you open the door, turns the interior lights on. When you close the door, the timer is going to keep the interior lights on for, say, 30 seconds. After 30 seconds, it would shut the lights off. What this did is you close the door, gives you time to still be able to see and get the key in the ignition. They had an ignition input on there. If you turned the key and started the car up, interior lights would immediately shut off. You don't want the interior lights on while you're driving down the vehicle because that will affect your ability to see out into the dark. Then they started getting fancier. Instead of a relay to just shut it off, they actually used what they call a theater lighting effect, and the lights would be on, and then they would slowly dim the lights. Now, this is controlled by the body computer. They have micro switches all over the place. When you come up and you have the remote, you hit the button to unlock the door, interior lights will come on. On many cars, there's a micro switch built into the door handle, so you can come up, you can just flip up on the door handle, and it'll light up the interior of the car. You can look to make sure there's nobody in there waiting for you. It also, by lighting up, if you have to use the key, it'll light up around the key. A lot of them had a halo around there. There was actually no bulb there. What they did was the bulb that was in the door just had a fiber optic that came up and lit up that halo. This is showing us where 3 lights, which was typical for a lot of vehicles. You start getting up in the higher end vehicles and they start adding more and more lights. So besides the 2 under the footwell and the 1 up above, they'll add another 1 up above, and then they'll add 1 on each of the doors. And besides the light on the door, they'll also put a puddle light to make sure that you can see if there's going to be a puddle when you're getting out of the car. And then they add a red light so that if there's oncoming traffic, they can see that the door's open. Now, there was one Bonneville that I was working on. It was part of a murder investigation, so they actually had crime scene tape set up around the vehicle. I was in there. The police wanted me, or not the police, but the state wanted me to go in there and figure out, okay, if the alarm would have gone off because this was a suspected car burglary that was interrupted that the guy got killed on. On that car, as I'm going through and reading the wiring diagram, there was 17 interior lights on that car. It's not just a simple 1, 2, or 3 lights like we've had. The system's gotten more and more complicated. Now, fiber optic is used for computers, for high-speed communication, because light does travel faster than electricity. The light is also not susceptible to EMI. And this is not that type of fiber optic. This is real low-tech. They've started putting this on cars back in the 60s. What you're looking at right here is the end of the fiber optic. The other end of this fiber optic actually went into the taillight housing. When you turned on the taillights, you would see these 2 lights come on dim. Hit the brakes, you would see them turn on bright. If you had the turn signal on, you would see it flashing bright, dim, bright, dim. This one right here with the 3 of them, this sat on the front fender. There was 1 on each side. 1 of it came from the low beam, 1 from the high beam, and 1 from the turn signal. When you turned on the headlights, you'd see this one on. When you turned on the high beams, you'd see this one and this one on. If you had the turn signal on, you'd see this one flashing. Here's your cabling over here. It just used a real low-grade plastic fiber cabling to bring the light from the housing up to this indicator. Low-tech lamp outage. If you had a bulb burned out, you'd see no light there. Today, the fiber optic, that's what you're looking at here. Man, you can do all kinds of stuff with the fiber optics. If you start doing this to customize the vehicle, keep in mind again, those fiber optic lights have to be out while you're driving down the road. Coming back and looking at our Park lights. We looked at one earlier, and this showed this coming off to here. And I've got the danger, Will Robinson, danger. When I'm working on a vehicle, it comes in and it's got a problem with the lighting. Not the headlights, but tail, brake, turn, something like this. One of the first things I try to remember to do is take a look at the back. Has anybody wired this thing up for a trailer? If they have, that's where I'm going to start my diagnosis. And most of the time, that's where the problem is. This one here, they wired this up for a trailer. These little plastic connectors right here are cheap. If you get a chance to use these, don't run away. What these do is they actually cut into the existing wiring, so they damage the wiring on the vehicle. The other thing is they're not environmentally sealed. You can see the tire right here. This is in the back of the car, just behind the rear tire, man. Dirt, mud, all kinds of stuff is going to get splashed up inside of here. On this vehicle, as several others, what I did, just ripped all of their trailer wiring that they added to there, repaired the damage that those connectors did, and now the lights on the car worked perfect. Then we need to wire up for the trailer. Looking at trailer wiring, first thing we'll look at is this pin here. This is a 4-pin flat connector that has the green, yellow, brown, and white. This is SAE standards for trailer wiring. Green is your passenger side or right side turn stop. Yellow is the driver's side turn and stop. The brown is your tail lights, side marker lights, identification lights. On the trailers, you'll see that there are 3 lights across the center. That is required by law, so vehicles coming up behind you know that they're coming up behind a trailer, which you'd think, hey, wouldn't that be obvious? But if you're driving on a dark, foggy road, you just see tail lights up in front of you. This is how you're going to identify that that's a trailer. Also, side markers, depending on how long the vehicle is, it may require just 1, 2, or 3 different lights on there for vehicle trailers. When you start getting into heavy duty, they require more. The second one, and this is again of the 2 most common, this is a 7-way, and they call it a 7-way flat, which got really confusing to me until I finally realized, okay, they're talking about flat pins as opposed to round pins. This is what the 7-pin connector would look like on most of the vehicles when you're getting up into half-ton, 3/4 ton, or 1-ton trucks that are going to pull a trailer. Looking over here, this is the side where the wires connect up. We have our brown, green, yellow, and white. White is the ground. Same as the home, your white is your neutral, your ground wire. Running lights, park lights, tail lights, license plate lights, all of those. Right turn, left turn. Now for the extra wires, the black wire, this is going to be a battery wire. It is charged up from the alternator on the vehicle. Purple for the reverse light. I have never noticed a trailer that had the backup lights on it. The blue wire right here is going to be for the trailer brakes. Trailer brakes work different than the automotive brakes. It needs to have a brake controller mounted in the vehicle to send a variable voltage signal depending on how hard you're braking. This is supposed to be SAE standard. If the trailer has been wired up correctly, if the vehicle has been wired up correctly, all the lights should work. To wire up the vehicle correctly, on my pickup, I have a 7-pin that looks like this. My pickup came with a trailer towing option, so this was already on there. If you have a vehicle that didn't come with it, you're going to have to mount this. You can buy this kit. So this connector here is similar type to this connector here. If you have a car, you want to pull just a small trailer with it, you're going to use that 4-pin for your lighting. Don't need to splice anything in. You can buy these adapters. This is a 4-pin weather pack connector. At the back of the car, you're going to find either on the driver's side or the passenger side this 4-pin weather pack connector. You unplug it. This goes in, plug it in. The male side here, female side here. Just need to add the ground somewhere. Trailer's now wired. If you have this style here and you're going to pull a small trailer, they have these adapters that this plugs right into here, and there's your 4-pin, so the trailer can plug into that. Here's our trailer. Years ago, a friend from church, and he had a boat, and I loved to water ski. I was talking with him, and as we were talking, we made arrangements to go water skiing together. And I was figuring that, okay, I'll do some work on your car, we can go water skiing. And I found out that he had the boat with the trailer, but his little minivan couldn't pull the boat. So he was actually looking for somebody that could take his boat up there, and I was looking for somebody to go skiing. Perfect match. Hooked the car up to the trailer and tested the lights. There was one light on the entire trailer that worked. As I started looking this over, looking, okay, maybe I can just make some repairs here real quick. This is a trailer that goes in the water. This behind the axle, and just over a 1 foot section, there were 3 splices. One splice was twisted together and had a Band-Aid wrapped around it. This was so messed up. And just like, forget this, cut all the existing wire off of there, went to the parts store, bought the trailer wiring, and then went through and wired up all his trailering, putting the environmental seals back on here so that this wasn't going to corrode or cause problems. Wired up his trailer. And this is showing you a 7-pin. On his, it was just a 4-pin. One of the things that you'll find that there's a lot of places that make trailers. They have some really great welders there. Man, they put these trailers together really nice, but they don't know wiring. And they will put cheap connections, and there's many a trailer out there that I've had to go through and fix the wiring on. Hope that helps you with the trailer and for understanding how the rest of the lights work on the car. So that's it for this video.